Welcome to GRECO's AIA Continuing Education program. This course is titled Designing with Aluminum Railings in Commercial Applications and is accredited by the American Institute of Architects for one learning unit. Before we start, I'd like to provide some background on GRECO. GRECO is part of CSW Industrials, a diversified industrial growth company with well-established, scalable platforms and domain expertise across three segments: industrial products, coatings, sealants, and adhesives, and specialty chemicals. GRECO was founded in 1991 in Windsor, Ontario, Canada, where its main fabrication plant and corporate headquarters is still located today. GRECO has its U.S. office and second fabrication plant in Hudson, Florida. GRECO designs, engineers, manufactures, and installs architectural railings and engineered metal products. GRECO services and provides products throughout Canada and the United States. The company's success has contributed to innovative designs, outstanding customer service, and unparalleled technical support. For new construction or restoration projects, GRECO has become the first choice of building owners, general contractors, engineers, and product specifiers. This course is approved and in compliance with AIA and meets its best practice standards. CSW Industrials is the registered provider with AIA. Here are the 4 learning objectives for this course. Understand railing types and applications. Understand methods of installation, performance, and applicable codes for welded aluminum railings. Understand the various design options and benefits of welded aluminum railings. And understand how to evaluate and specify welded aluminum railings. This course will discuss the following topics: railing types and applications, railing components and options, mounting methods, aluminum finishes, fabrication capabilities, codes and performance, product evaluation. Architectural aluminum railings offer designers multiple design and performance benefits. Aluminum is an extremely versatile product, offering fabrication flexibility for custom and standard shapes, a variety of finish options, provides beautiful aesthetics, and has great structural integrity. Aluminum is also recyclable and environmentally friendly. Architectural railings are continually evolving and engineered to meet the most demanding national, regional, and local building code requirements. The International Building Code, the IBC, continues to address railings and adopt more stringent policies. Today's railing fabrications must be equipped to meet or exceed these ever-changing code requirements. Aluminum railings offer a variety of appearances with a multitude of top rail options in both custom and standard sizes and shapes, with supporting post and various infill options. Many fabricators offer traditional shapes, while other fabricators offer unique designs and options with proprietary materials, and offer installation or approved installers to provide a high-quality installation with an on-time performance. Aluminum as a material is an incredibly versatile product. It can offer a variety of appearances with high-performance characteristics with uniformity in its quality. From a railing design standpoint, it offers a wide range of finishes with multiple options in top rails and railing post shapes and sizes, and allows for a multitude of infill options. These design options offer everything from traditional railing systems to the most exotic custom designs. Today's best railing fabricators can meet the most challenging railing designs. They engineer, fabricate, and powder coat in-house, providing cost-effective railing systems that meet both the desired aesthetics and performance criteria. Aluminum is corrosion resistant and will not rust. This means it requires little maintenance. When following the fabricator's maintenance guidelines, an aluminum railing can maintain its original finish for an expected lifespan. Aluminum is 100% recyclable. It's non-toxic and contributes to sustainable design. Aluminum also allows for complex integral shapes for ultimate customization. A well-engineered and fabricated aluminum welded railing system should require little to no maintenance under normal use. Following a regular maintenance cleaning program will protect the longevity of the railing system that may be expected to unusual abuse or damage. Technologies are constantly being developed to enhance the aluminum finish and extend the life and durability of the product. There are three basic types of aluminum railing system methods of assembly: mechanical, direct welded, and punch-and welded. Mechanical, as the name implies, is a railing system that is mechanically fastened and held together with screws, rivets, or epoxy. The system may initially seem low cost, but there are many potential issues that can contribute to a low quality product longevity, and total in cost. There is a higher cost of labor due to field fabrication cost. Mechanical fasteners have a tendency to loosen and the railing system become unsafe over time. The quality of the product is only as good as the mechanic who has field fabricated all the parts that were assembled. The system can rattle if not assembled properly. The system is only as strong as each individual post. The safety factor is only as good as the field fabricator explicitly following all installation instructions. Cut-ins of components open up the paint surface where filiform corrosion can originate, thus compromising the finish. In general, welded systems offer superior performance over mechanical systems, providing minimal maintenance, allowing for custom designs with a factory finish and unified construction. Whether it's a direct welded system or punch-and welded system, there are some distinct advantages with direct welding. Lower cost of installation labor, with typically half the installation time, provides a big cost savings. Welded systems provide high strength to the overall systems, as all connections are welded, which is much stronger than mechanical connections. The only mechanical fastener used are to bolt the system to the building and stainless fasteners at all splice locations. The welded unitized system transfer design loads throughout the railing to adjacent post attachments. And lastly, with welded systems, you get the highest level of quality control, as all the systems are fabricated in the factory under a controlled environment. There are no exposed ends of aluminum, as all are fully powder coated in the factory. Welded railing systems are typically the mark of a premium high-end system. Direct welded systems provide strong, high-strength joints. When fabricated in a controlled environment, it offers superior control quality. Direct welds also allow for highly customized designs with the ability to offer the desired performance of the system. As railings are a life safety device, it should be noted that welding must meet the proper strength specifications for aluminum structures. This is another area where a reputable manufacturer should be specified for the fabrication of welded railing systems. A punched and welded system is when the vertical components goes all the way through the top and bottom rail. A profile top rail is fully welded into place, providing additional strength and overall integrity of the system. Punch is accommodated with computerized tooling and conceals the welding to the underside of the horizontal components. This creates a very strong assembly with the combination of the weld and the fact that it is punched through another piece of aluminum, which adds additional strength to the system. The punched and welded systems offer a far greater level of performance than the mechanical or direct welded systems, allowing it to meet or exceed the required IBC concentrated load performance standards. Exterior architectural railings can be used in various commercial applications, with the design goal to offer safety, performance, and aesthetics. There are a variety of aluminum railing types that an architect and owner can select, depending on the desired aesthetics. The most common type of aluminum railings are picket, glass, metal panels, cables, or custom designs. The most commonly used railings are picket railings, or also referred to as a balustrade railing. These traditional railing styles are still the most popular railings in the commercial market and are used worldwide in schools, hotels, condos, both high and low rise, apartment buildings, office buildings, and much more. They are also the most cost-effective option. Picket railings are cost-effective systems that can be designed and customized to meet a specific project need while meeting all of the safety and code requirements. Glass is one of the most popular railing systems at the moment, particularly for high-rise multifamily and hospitality designs. This presents occupants with a clear view, which is a huge selling feature for the owner or landlord. Per the 2012 International Building Code, glass used as a handrail assembly or as a guard section shall be constructed of either single, fully tempered glass, laminated fully tempered glass, or laminated heat-strengthened glass, depending on the application. This has since changed with the introduction of the new IBC 2015 code, which will be covered later in this presentation. Glass railings offer architects and owners a modern design, offering various options from clear, tinted, or opaque glass. These glass railings can also provide a wind barrier. Glass infills should be 5/16 to 7/16 inch thick and must be laminated glass to meet the current 2015 International Building Code for glass used in handrail assemblies or as a guard section. The popularity of glass railings is driven from its ability to offer the highest level of performance with a clear, unobtrusive view. Various glass makeups and thicknesses can provide the performance needed to meet specific code requirements. Depending on the code requirement, it may dictate the type of glass used in the railing system. For example, in the hurricane regions where there are specific codes for windborne debris, a 9/16 inch laminated glass is typically used. These hurricane systems must be tested and approved before it can be approved for installation. Code requirements will determine the thickness of the glass. The minimum allowable glass infill option is now 5/16 laminated heat-strengthened glass. There are three basic types of safety glass used today in glass railings. Fully tempered glass for those projects were designed prior to the 2015 IBC. Laminated glass with polyvinyl butyryl interlayer and laminated glass with ionoplast interlayers. Each have some unique properties and can be defined as a good, better, best product option. Fully tempered glass is 4 times the strength of anneal glass and provides the strength needed for severe wind loads. From a safety standpoint, it is considered safety glass because when it breaks into small pieces. The debate with fully tempered glass as an infill for railings is that it may be deemed safe for fall protection, but the infill is completely lost once it's broken and the opening is breached. Laminated glass with PVB or polyvinyl butyryl not only meets the safety glazing standards, but it also offers the advantage of staying in place after it's broken. In order to stay in place, laminated glass needs structural support on all 4 sides. If both layers of glass are broken, it can still remain in the frame, minimizing any fallout, creating both safety from falling glass and maintaining itself in the opening. Laminated glass with an ionoplast interlayer offers the best advantages of all. It is a much more rigid glass makeup, especially after the glass has been broken. With the ionoplast interlayer, the laminated glass can stay rigid and upright without side or top support. There can be a pretty large differential in the price of glass railings depending on what type of glass is used and the railing design. As exact pricing can vary by region and manufacturer, you can break it down as a good, better, best scenario with a standard glass railing design, a base shoe structural design, and lastly a point supported glass railing. The choice of glass will also play a role in the overall pricing of the railing. Tempered glass will be least expensive, if not serving as fallout protection. Laminated glass can be anywhere from 4 to 10 times more expensive than tempered, depending on the laminated makeup and interlayer used. Metal panels, although not as contemporary as glass, can offer the architect and owner a cost-effective option, especially when privacy is desired or when the objective is to conceal items behind the railings. Recently, the popularity of metal panels have picked up with perforated panels, providing a stylish option to the metal panels. Cable railing systems offer the architect and owners a very clean, contemporary look. Cables can run horizontal, vertical, or even a mesh design, offering a unique yet functional railing system. However, keep in mind that some local building codes don't allow horizontal cables due to the climbability issue. Custom railings can be as unique as the designer's imagination, combining the various materials discussed and creating one-of-a-kind railings. Complex shapes can be created with unique infills. The architect will need to work directly with the fabricator on custom railings to ensure that all performance standards are met. This project in Chicago is a great example of creating a custom railing system that not only meets all the performance standards and building codes, but aesthetically it complements and helps define the facade of the building. From simple railings to highly creative designs, railings can complement or even define the design of a building or home. Most commonly, you will see balcony railings on mid to high-rise multifamily projects. Other railing types include stairs, patios, pools, entrances, and guardrails. Although the railings can add a significant architectural design to the building, the main intent should always be to provide safety and be in compliance with IBC and local building requirements. Working with an established and forward-thinking railing fabricator who can offer the latest product offerings, technologies, and engineered systems can offer the best product solutions for your project. Beyond the applications we just discussed, railings can be used in a multitude of ways, be it to secure a space, define an area, provide a safeguard, or add a decorative exterior element to a building or an outdoor space. Architectural railings can be a critical part of a renovation project, providing a new, updated look or creating a new point of interest, and can be customized to virtually any design style and shape. In new construction, railings may account for a small portion of the overall budget of the project, but it is typically a major design element both aesthetically and from a performance standpoint. When designing or specifying a railing system for mid and high-rise buildings, there are a number of components that come into play that can impact the design of the railing. Commercial railings offer a multitude of standard and custom components that can dramatically change the look of a commercial railing system. By changing or selecting various components of a system, architects can create unique and one-of-a-kind designs. In its most simplistic form, there are 4 key components of a typical railing system: the post, top rail, infill, and base plate. Slab covers are an option to conceal the concrete slab. The difference in railing systems are how they are put together or fabricated and the materials that are used. Here are 2 railing details. The first system has the standard post, top rail, and base plate with a surface mount. The infill is a flat metal panel. In the second detail, we again have the standard post and top rail, but with this design it has a parapet mount with a glass panel infill. Spacing of the railing post is critical in both structurally supporting the railing and meeting specific code requirements. Additionally, it is part of the aesthetic design of the system and contributes to the overall look of the facade. Top rails are typically offered in standard geometric shapes. However, certain railing fabricators offer proprietary shapes and have the ability to offer custom designs. Although top rails may seem like a minor design detail, it can actually help define the overall design of the railing system, and the top rail is just as important to the structural design of the system as the post and base plate connection. Railings have come a long way since the 1950s, when most balcony railings were just simple painted wrought iron in a vertical configuration. While the traditional vertical picket is by far the most popular option, railings designed with infills offer a variety of design options. Some of these infill options include perforated panels, woven wire, solid metal, and glass, which we've discussed. Unique railings can be created by the combination of the different materials. Railing infills provide architects and owners the flexibility of creating a variety of railing designs, offering a unique look for each project. Depending on the type of infill, you can create various levels of privacy, or you can completely conceal the contents of the balcony. Perforated metal infills offer architects a durable and industrial look while meeting the IBC codes. The architect and owner can determine the size and shape of the perforation as well as the finish. Woven wire or mesh infills have become somewhat popular in reuse or retrofit projects, such as industrial spaces that have been converted to residential or retail space. Typically, a 2-inch mesh will be as small as a fabricator will offer. The largest mesh is typically 4 inches, not allowing the passage of a 4-inch sphere. We mentioned metal panels earlier. Again, this infill option is typically dictated by price and the ability to conceal contents of the balcony. We spoke in detail about glass railings. With glass infills, it offers architects and owners a modern design, offering various options from clear to opaque glass. These glass infills can also provide a wind barrier if needed. Glass infills should be a 1/4 inch to 7/16 inch thick and must be laminated glass to meet the current 2015 International Building Code for glass that's used in guardrail applications. Glass infills will offer architects and owners an enormous amount of design flexibility while providing a very contemporary look. By tinting the glass or using colored inner layers in the laminated glass, you can control the opacity of the glass and the level of desired privacy. The railing base plate is typically dictated by the railing type or design, but can be customized. As the base plate is the structural connection between the railing and the substrate, it is engineered to meet specific performance criteria, as well as project-specific wind loads. Another design feature that can alter the overall appearance of a railing design on the concrete slab is an aluminum slab cover. Slab covers are most commonly used when there is exposed concrete. An aluminum slab cover can be designed to match the railing finish and offer a complete design look, or match other architectural elements of the building. Our next section will look at how railings are mounted. There are 3 basic installation methods of mounting a railing system: a facial mount, a surface mount, and an embedment. Here is an example of a surface-mounted railing, considered one of the easiest installation methods. One of the key installation advantages is that it can be installed while working on the deck. This means the installation crew does not need to work off of a lift from the outside. They can set up the railing system from inside the building and secure it right to the surface. Railings can be mounted to practically any surface, typically concrete. Next, we have fascia mounted installation, which has become more popular in recent years. A popular application for fascia mounting is with Juliet balconies. Shown on the left image in this application, the International Building Code states that posts are required with mounting back to the building in order to comply with engineering requirements. These mounting plates need solid blocking behind the walls for structural support. The image on the right is a typical fascia installation. It's best to work with a qualified railing manufacturer who can help engineer the system with an integrated building design. You should receive product data, CAD drawings, and details of the system from the railing manufacturer. By working with the right railing manufacturer up front, you can help assure that you address all potential design issues prior to construction. With an embedded installation, the installer will have to use concrete blockouts or core drill the slab. Additionally, you should not use a core mount embed detail in extreme climates that can have significant freeze and thaw cycles. The finish on aluminum railings is critical in both appearance and performance. In this section, we'll look at the different types of aluminum finishes for railings. There are 3 types of coatings or finishes for aluminum: anodizing, paint, or powder coating. When specifying aluminum railings, the desired finish and performance should dictate the finish you select. Anodizing is a simple electrochemical process developed more than 75 years ago that forms a protective coating of aluminum oxide on the surface of the aluminum. The lifetime of the finish is proportional to the thickness of the anodic coating applied. Aluminum oxide is a hard, durable, weather-resistant substance that protects the base metal. The coating may be colored by dyeing or may exhibit bronze tones. The coating is integral to the metal and cannot peel or flake. Anodizing is most commonly used on mechanical railing systems and seldom on welded assemblies, given that the anodizing would have to be done following the welding operation. Wet paints used as liquid coatings for aluminum railings encompass different types, such as acrylics, fluoropolymers, polyesters, and siliconized polyesters. Each coating contains pigments and resins or binders, which are the primary basis for their classification. Paint finishes on aluminum must undergo an initial pre-treatment process. If this cleaning is not performed, the paint won't adhere and could later flake off. This pre-treatment varies from a degreasing spray to the spraying of a zinc chromate primer. Next, the paint is applied. These wet painted extruded products are then baked in order to dry and harden the new finish. Facilities must have VOC emissions control systems due to the high VOCs emitted. Painted aluminum offers a wide selection of colors, can produce a smooth surface, and offers excellent corrosion resistance. The disadvantage includes high VOCs, color or finish may vary depending on process, and there can be quite a bit of waste due to overspray. Powder coating became commercially viable in the 1960s as an alternative to liquid coating, which were considered environmentally damaging. Today, powder coating is used throughout the construction, architectural, and interiors industries. Powder coating is a dry powder that is applied electrostatically to a metal substrate, such as aluminum. Once the base metal has been coated in the powder, it is heated in an oven, which causes the coating to melt. The intense heat transforms the powder element into a slick and continuous layer that adheres to the aluminum. Powder coating creates an attractive, durable, high-quality finish, which serves to increase the life of the installation. Powder-coated surfaces are more resistant to chipping, scratching, chemicals, fading, and general wear and tear than other finishes. It is highly recommended to use a certified applicator for powder coating, providing the highest quality control. Powder coating produces no VOCs while offering a decorative finish with the ability to custom match colors. It offers high durability and meets the AIA standards for finishes. Here's an overview of the AIA specifications for finishes. We have AIA 2603, 2604, and 2605. These are the industry standards for the performance of paint finishes. Architects and building owners should determine which performance specification is required, along with the paint color. In order to ensure the paint performance for a given application, one of the three AIA specifications should be referenced: AIA 2603, 2604, and 2605. These three specifications apply to progressively stronger levels as indicated by South Florida outdoor exposure and laboratory accelerated testing results. The two AIA specifications that should be considered for aluminum railings are AIA 2604 and AIA 2605. AIA 2604 is the preferred finish for railings according to PPG's internal studies due to the surface hardness of the finish versus those obtained when using the AIA 2605 powder. AIA 2604 is an intermediate performance specification, but is the recommended product for use on railings. A paint meeting this specification would be a 50% fluoropolymer. An application for this paint would be storefront, doors, railings, or other high traffic areas. This finish will provide good color and gloss retention. It also provides good hardness and abrasion resistance. In comparison, AIA 2603 is a softer finish, making it more likely to scratch over time due to normal use and cleaning. AIA 2605 is the high performance exterior specification. A paint meeting this specification would be a 70% Kynar 500 PVDF resin-based coating. These finishes exhibit outstanding resistance to humidity, color change, chalking, gloss loss, and chemicals. An application for this finish would include monumental architectural projects on areas of the building where occupants don't touch or are frequently maintained. As part of the testing requirements, the powder coat is tested daily for corrosion resistance and coating adhesion according to industry standard specifications. It is also tested in an accelerated weathering environment for several thousand hours to test weathering quality. After 5 years, or 10 for AMA 2605, of outdoor installation in conditions like southern Florida, the powder-coated product should have almost no color change and exhibit very little chalking. Periodic cleaning with a mild soap and water will enhance it and help to protect it from harmful agents. Southern Florida is used because the environment there is harder on powder-coated products than other environments, as it has both intense sunlight, high humidity, and wind-borne salt spray. Regardless if the coating meets AMA 2604 or AMA 2605, the finish is only as good as the pre-treatment. Any quality fabricator should have the following pre-treatment processes in place. First, the aluminum parts should be loaded evenly onto the horizontal hanger that is placed on the conveyor in preparation for a 5-stage pre-treatment wash. The 5-stage pre-treatment wash should consist of cleaning the aluminum so that it is free of any organic and inorganic contaminants. This system provides superior pre-treatment to the aluminum parts for the powder coating final quality, appearance, and performance. The aluminum must be sent through the drying oven where the moisture from the pre-treatment stage is removed. Parts normally spend 2 to 4 minutes in the oven around 380 to 420 degrees. The conveyor will move the aluminum through the powder coating booth at a steady rate so that the application guns cover the aluminum properly in order to meet the AMA 2604 or 2605 standards. The powder should be cured for 8 to 10 minutes at around 330 to 460 degrees depending on the color and the part's density. When the aluminum is cooled, it is then unloaded and packed for shipment and delivery to the customer. Selecting the right railing fabricator is critical to the success of your project. The fabrication capabilities of a company can define its overall offering and quality of product. Companies that value quality and consistency in their product typically have the following: CNC, which offers a high level of sophistication and consistency to the fabrication process compared to a company who manually assembles their products. Welded products offer added strength and longevity to the railing system versus non-welded or mechanically fastened systems. In commercial applications, it's critical to have a fabricator that can engineer custom shapes and designs when needed. All fabricators should be committed and in compliance to industry standards. A fabricator should be able to not only meet design specifications, but should be able to work with the design and provide design recommendations. All reputable railing fabricators should have a quality control systems in place and in-house testing. Advanced fabricators will use robotic welding to produce the highest quality at the most affordable pricing. When an architect is evaluating or specifying a railing system, these capabilities should be examined in detail. A railing system is only as good as its performance and ability to meet or exceed all of the safety code requirements. This is a brief overview of the specific performance and code requirements for commercial glass railing systems. Code requirements are constantly changing, and it's critical that the railing manufacturers stay on top of the most current codes and standards that are related to railings. Specifiers and owners must be careful in selecting a railing manufacturer, as some companies will offer low-cost options that may not meet the current building code requirements. In working with a reputable railing manufacturer, you can be assured that their engineering staff offers only the highest level of quality while meeting the required building codes. In this section, we'll look at the 2015 IBC related to the load requirements for glass railings. The International Building Code, or IBC, is a model building code developed by the International Code Council, or ICC. It has been adopted and used as a base code standard throughout most of the United States. The IBC has long been the governing reference manual for determining minimum load requirements. The 2015 IBC minimum design load requirements for glass guardrails fall under 4 sections. Handrails and guards, this is IBC section 1607.8.1. Concentrated load, this is IBC section 1607.8.1.1. intermediate rails, IBC section 1607.8.1.2, and then loads, which is IBC section 2407.1.1. We will take a brief look at each one of these code requirements that are critical to glass railings. Handrails and guards shall be designed to resist a load of 50 pounds per lineal foot applied in any direction at the top, and to transfer this load through the supports to the structure. Handrails and guards shall be able to resist a single concentrated load of 200 pounds applied in any direction at any point along the top, and to transfer this load through the supports to the structure. Intermediate rails, which would be all those except the handrails, balusters, and panel fillers shall be designed to withstand a horizontally applied normal load of 50 pounds on an area equal to 1 square foot. Section 2407.1 on loads state that the railing panels and their support systems shall be designed to withstand the loads specified in section 1607.8. A safety factor of 4 shall be used. It's important to understand that the minimum load requirements provided in the IBC are design loads provided for engineers to be used in the completion of calculation reports. In order for glass railings to be considered code compliant by testing methods, the glass railing manufacturer must work with an International Code Council approved testing facility, and the testing facility is required to follow the ICC-ES AC 439. The ICC-ES AC 439 testing procedure uses code-defined minimum loads and deflection requirements along with the appropriate safety factors for the glass and other railing components. These tests are performed on complete glass railing systems and not isolated components such as the base shoe, top rail, handrails, and glass. In addition to the load requirements that we have just discussed, there are other code and performance criteria that the manufacturer must meet and the architect must be aware of. Guardrails or railings are first and foremost to provide safety and protection. The IBC requires a guardrail to be 42 inches in height. Handrails are located between 34 and 38 inches and have dimensional limitations for graspability. As such, if a 42-inch guardrail is called for on a stair or ramp, it will also require a secondary handrail at the appropriate height. A guard top rail that is not used as a handrail would not have a graspability size limitation. Guards also have opening limitations to consider. The most common requirements is that no opening be large enough to allow a 4-inch sphere to pass. For glass railings, to meet the required safety requirements, the glass must be constructed of either laminated fully tempered glass or laminated heat strengthened glass. Glass infill shall be of an approved safety glazing material that conforms to the provisions in section 2406.1. For all glazing types, the minimum nominal thickness shall be 5/16 of an inch. Laminated glass shall comply with Category 2 CPSC 16, CFRC 1201, or Class A or ANSI Z97.1 listed in Chapter 25. Keep in mind that our discussion is a very broad overview of codes related to railings, and that every state and municipality may have different code requirements. Here is a short list of codes and standards that are typically referenced in the design and installation of commercial railings. You should work closely with the railing manufacturer to make sure all the proper codes are met and that there is full understanding of the requirements for each project. Our last section before we look at some case studies is product evaluation and specifications of commercial railing systems. These are some recommendations on the selection and specification process for commercial railings. Doing your due diligence in selecting the right railing system is critical to the project's success. Working with a reputable railing fabricator with a strong track record is vital to being able to get the support and information needed. Here is a checklist of items that should be considered when starting the design process. First, determine if you're looking for a custom or standard railing system. If it's a glass railing system, determine what type of glass products or your glass options are. Research the fabricator that you're working with or considering. Compare fabricators' capabilities. Request product performance data sheets, test reports, and, if appropriate, ask for plant tours. Mock-ups and/or samples are critical in determining the aesthetics that you're looking to achieve. Case histories of similar projects will help determine if there's been similar projects that have been done with the performance criteria of your project. Request project references. Project literature, warranty information, and even lead information can all be vital in the overall research and due diligence of the products that you're looking to use. The following information related to your railing system is critical and should be included in your specifications, starting with colors, material types, glass type, post spacing, welded systems versus component systems, the glass thickness, the specific codes and standards, if there's a sample submittal requested, if there's any mock-ups that are requested, either small or full size, any test reports related to the performance needed for the project, specific shop drawings, the manufacturer's certifications, maintenance information, and any related warranties. 3 key areas that should be considered in any product evaluation specification should include structure and performance, aesthetics, and execution and delivery. With structure and performance, you should include the following information, documentation, or requirements in your specifications. Fully welded aluminum only by certified fabricators. Installation, means and methods of attachment to the structure. Structural requirements and wind loading. Powder coat, color, and glass options. Project specification engineering. Full-scale mock-ups. Field testing. And paint specifications, either AIA 2604 or AIA 2605. For aesthetics, you should include the following items in your specifications: the design of the top rail profiles, the infill design options, whether picket or glass, and if glass, if it's tempered or laminated, or if it's tinted in color or a frit pattern, and if it's front, center, or back glazed. You should also specify if there will be a slab edge cover for the railings. For execution delivery, you should have specified the field measurements that are needed prior to production, the delivery coordination, the certified installers, a final inspection, and the product warranty. As with most major architectural building products that you are specifying, we recommend requesting a CSI 3-part master format spec for the railing systems that you are specifying for your project. Our last section of this course will highlight recent high-rise projects that have specified and used glass and aluminum railings. The first project is located in Chicago and called New City. New City was designed by OKW Architects and constructed by Power Construction. 4,745 lineal feet of GRECO's surface-mounted glass railing system was specified and used. One of the key advantages of the glass railing system is that it does not obstruct from the incredible view from inside the residential units. The next project is Country Club Tower 2, located in Denver, Colorado, and was designed by Solomon Cordwell Bwens and constructed by Swinnerton Builders. In this project, just under 5,000 lineal feet of GRECO's custom-engineered aluminum and glass railings were specified and used. Next, we have One Light Tower, a Cordish Properties development located in Kansas City, Missouri. This project was designed by Humphreys and Partners Architects and constructed by J.E. Dunn Construction. Here we had 2,250 lineal feet of GRECO's aluminum and glass railings that were specified and used. Here we have the Tyndall at Robertson Hill in Austin, Texas. This is another project designed by Humphreys and Partners Architects and built by White Construction. This 6-story luxury residential building used a custom aluminum wire mesh and glass railing system that was engineered and fabricated by GRECO. Architectural railings continue to evolve and play a major role in many commercial and high-rise residential projects. Architects need to be aware of current and ever-changing railing requirements mandated by building codes. Partnering with an experienced and reputable railing fabricator can pay great dividends on your projects and should be a major resource in engineering and designing the perfect railing system. With quality and design capabilities in mind, architects and owners alike should seek out the most effective manufacturing technology to support the various top rail designs, shapes, and sizes for the assorted post and infill options incorporated in their custom railing designs. Here are some key takeaways from this course. Architectural railings can help define a space while providing a mandated level of safety. Glass railings can offer a unique design element to either the exterior or interior of a building. There are various components to a railing system that can be customized to create a one-of-a-kind system. Powder coating offers a durable, aesthetically pleasing, environmentally friendly surface finish. And welded aluminum offers distinct advantages over other materials and fabrication processes. This concludes our AIA course presentation. Thank you for your time. To complete this distance learning portion of this course, you will need to take the course test of 10 questions and get 80% or better correct. If you would like any additional information on GRECO aluminum railings, you can visit their website at www.grecoarchitecturalmetals.com or call 1-800-363-7245.